Okay, let's go over quiz number 8. So with number 1, we have the sigma, and it starts at 1 and goes to 5. So we start by plugging in 1 in for n, and we add each term after that, plugging in 2, 3, 4, and 5 in for n. And for each term, we're going to just keep increasing until we reach 5 for our value of n, at which point we stop. So this is equal to -6. This is equal to 12, -24, plus 48, minus 96. And so to find the value of this, we sum them all up. And so we should get -66. For the second one, we're adding 1/2 plus a 4th plus an 8th plus a 16th plus 1/32 plus 1/64. Now the tops are all the same. They're all 1, which is great for a formula, but the bottoms keep changing. Well, we can rewrite the bottoms as 2 to the first, 2 squared, 2 cubed, 2 to the 4th, 2 to the 5th, 2 to the 6th. So here they're all the same, but what's going up is just the power on 2. So as a sigma, we can start with 1, go up to 6, and our formula is 1 over 2 raised to the nth power. For number 3, we're taking this binomial and raising it to the 5th power. So our coefficients are going to be 1, 5, 10, 10, 5, and 1. And we start with 2x to the 5th, and then 2x to the 4th, and we continue this all the way down till we have 2x. Now technically it's 2x to the 0 on this term, but we don't need to write that. And then on this term we start with -5y, and then -5y squared, -5y cubed, -5y to the 4th, and -5y to the 5th. Now, a lot of people made the mistake of leaving it as it is right here, but you want to expand this out so that we can see the coefficients for each term. So with this first term, it's going to be 32x to the 5th. The second, it's going to be 5 times 2 to the 4th times -5. So it's going to be minus 400 x squared, x to the 4th y. Then we have 10 times 2 cubed times -5 squared. So that means we're going to add 2,000 x cubed y squared. And then 10 times 2 squared times -5 cubed. So minus 5,000 x squared y cubed. Then we have 5 times 2 times -5 to the 4th. So we're going to add 6,250 x y to the 4th. And then we subtract 5 to the 5th, which is 3,125 y to the 5th. So this is what our expanded binomial should look like. At number 4, we're taking square root of x plus 4 to the 4th power. So our constants are 1, 4, 6, 4, 1. And so we have square root of x to the 4th, square root of x cubed, square root of x squared, square root of x. And then onto that we have 4, 4 squared, 4 cubed, 4 to the 4th. Again, you don't want to leave it in this form. You want to expand it out. So when you have square root of x times square root of x, that's just x. But now we're doing it 4 times. So here we have x squared plus 16x. And we have a square root of x left over, so we just write it as x square root of x. Then we add 96, that's 6 times 4 squared, x, plus 256 square root of x, plus 256. All right, so let's move on to number 5. With number 5, you have to find the term that doesn't contain the variable x. And so we start by raising it to the 6th power. So 1, 6, 15, 20, and then 15, 6, and 1. Now here we start with x squared to the 6th power. Well, there's no 1 over x to cancel any x's out, so that's not going to happen. Not on that term. For the second term, we have x squared to the 5th times 1 over x. Well, this is going to be x to the 10th times 1 over x. They won't cancel there. So we move on to the next term. X squared to the 4th. That's going to be x to the 8th. And here we have 1 over x squared. Well, that's not going to be enough to cancel those. We want the powers to be the same on x. So here we have x to the 6th. Can we get x to the 6th on the bottom here? Unfortunately, we just have x cubed here. So we have to keep going. Here we have x squared squared times 1 over x to the 4th. Here we go. Here we have x squared squared, which is x to the 4th, and then we have 1 over x to the 4th. These will cancel. And since they cancel, the only thing that's left is the number, which is 15. With number 6, we want to find the probability of flipping a fair coin 4 times and getting at least 2 heads. So here we have h plus t to the 4th power. So there's one way to get 4 heads. There's 4 ways to get 3 heads and a tail. 6 ways to get 2 heads and 2 tails. 4 ways to get a head and 3 tails. And 1 way, to get 4 tails. Now what we're concerned with is finding the probability of getting at least 2 heads. So we want those 3. So what we do is we plug in 1/2 in for h and 1/2 in for t, because this is a fair coin. Heads and tails have equal chance of happening. And what we get is 11 over 16 when we expand those numbers out. So for the final one, it asks, you're taking a 10-question multiple choice quiz. Each question has 4 choices. What's the probability of getting 8 or fewer right if you're guessing randomly? Well, for each question, you can either guess it right or guess it wrong. And there's 10 questions. Now this would be quite the binomial, but we don't need to expand it out to find every term. Rather, let's start with the first term, r to the 10th. Well, we're not going to include that one, but let's keep going. 10r to the 9th w. We're not going to include that. But every term after that we would include, because it says 8 or fewer. Well, we could waste our time trying to find each term, or the alternative is, well, these are the 2 terms we don't want. Let's find them and then subtract them from 1. Now, because each question is multiple choice, that means that we have a 1 in 4 chance of getting any question right. So we put 1/4 in for W, since there are 4 options. And that means if there's 1 right answer for each question, then there's 3 wrong answers. So that means the probability of getting it wrong is 3/4. So now we calculate 1 minus 1/4 to the 10th minus 10 times 1/4 to the 9th times 3/4. And we get 0.99997. So it is almost assured that we will get 8 or fewer right. Thanks for watching. Hope this helps.